Thank you, Elliot. Yeah, I'm very grateful to have the opportunity to present this work with Canvas. To provide a bit of motivation, one of the key features that we think distinguishes digital goods from more traditional retail goods is this joint ability to price dynamically and the presence of consumer data. And so the running example that we're going to use throughout this talk is a streaming service or a new streaming service that has a library of like movies or TV content and has access to information about consumer tastes. And so we're initially going to think about the sellers as being informed somewhat about their consumer population. And we think it's really important to consider dynamics as well, in that for things like, we're a streaming service where you have movies and content, buyers learn from their experience. So in fact, in the long run, we anticipate that buyers will understand better than the seller what their own willingness to pay is. And an important feature of sort of these environments that allows for interesting seller dynamics is that sellers frequently have the ability to commit somewhat to future prices and access. So I can agree to charge like a $9.99 service fee for access to my streaming trial over the next year or something. So the main questions we're going to ask in this sort of environment first are, one, what dynamic pricing mechanisms optimize and inform sellers' revenue? And so we're going to first note that in our framework or environment, the seller has some information. And as a result, because the seller has information, also what sort of pricing mechanisms get offered convey signaling content. And so we're going to also ask how these signaling incentives will affect what mechanisms end up being chosen in equilibrium. And lastly, if I hopefully I'll have time to get to all of this, we're going to ask how the seller's screening technology impacts their pricing strategies and revenue. And I'll be more specific on what I mean by screening technology, but we're going to think about giving the seller more instruments to mess with the quality and information arrival rate of their service. Okay, so I'm going to jump into the model. I have two players, seller, buyer. You can think of sellers like the streaming service. The seller is selling the service to the buyer in continuous time for a finite time, up to time t. There's going to be no discounting. The results will go through. If you do infinite time with discounting, it's just cleaner and easier to see the insights this way. There's a match quality, which the seller is aware of. It's either low or high, it's binary quality. It's persistent over time. It's high with some probability mu0. And this match quality is observed by the seller, but not by the buyer. So this is private information to the seller. And the seller is going to have some lever that they can control over time, which is, we're going to call this service access. For a streaming service, this could be like, I can rate limit how much you can watch, or I can restrict my library of content. They have some lever that they can use to control access. And access is important because the buyer only gets utility rewards from using the service, and these rewards arrive stochastically depending on their level of access. So the buyer will get private lump sum rewards of some size, B, at a Poisson rate. And note that I scales the Poisson rate, so the more access the seller provides the buyer, the faster these utility shocks arrive. And so you can imagine for a streaming service, this is like stumbling upon content that resonates with my taste, I get like a positive utility shock, and I'm happy. This reward size V is initially unknown by everyone, we assume. But it is observed by the buyer when or if it arrives. And so we treat this entire reward utility process as being private to information to the buyer. I understand how much I'm enjoying or not enjoying the service. This is not observed by the seller. And so the seller would like to be able to somehow exploit the fact that the buyer is seeing something and trying to take advantage of the learning process that the buyer has. And the seller really is going to try to do this by getting the buyer to make flow or instantaneous payments to the seller. And I'll be more formal about exactly what I mean about the mechanism in a few slides.
V is persistent?
V is persistent, yes. Sorry, I should have.
What's the interpretation of I?
It's service access. So if I'm a streaming service, I'll treat this as like, I can restrict how much you can watch in a certain period of time or something, which limits the rate at which you learn, but also the rate at which you experience positive utility from that service. Okay, so payoffs are actually sort of super straightforward. When the game ends, let's suppose the number of rival rewards is big N and the cumulative payment is P. Seller's payoff is just P, buyer's payoff is NB minus P. There's no discounting. It's very. So the timing of the game is that nature is first going to draw this match quality, which binary match quality theta, and the value of the buyer B. Theta, or this match quality, will be observed by the seller, and the seller will then publicly propose some kind of dynamic mechanism. The buyer will either accept or reject this dynamic mechanism. If they reject it, it comes out on 0, and upon acceptance, the mechanism will start and both parties start reporting messages. So what is a mechanism? We'll consider the set of direct mechanisms. So there's two-sided private information. The seller has this information about the match quality. The buyer has this private learning process. And so the mechanism will require both parties to report. The seller will report their private information at the beginning, and that's the only private information they have. So that's there throughout time. The buyer has this learning process, but what is really payoff relevant to the seller and to the mechanism is really whether the buyer has seen a reward arrive yet. Because once the reward arrives, if this utility shock happens, then one, I am convinced that the seller is high type because I could not have gotten a reward if there was no match. And two, I also know and understand the size of my utility shocks. Okay, so the message space informally is this like raise your hand kind of mechanism where the buyer at some point will signal that or indicate to the mechanism that I have received a signal, its size was B. And the history will record reports of the buyer and seller. And so a mechanism is really a pair that maps these histories into how much access. So we denote as service access under each history. So for every time, it's a function that maps what the history of messages is into what access the seller is going to provide. And P is cumulative price path. It's easier to work with cumulative for our purposes. But you can think of this as incorporating flow and instantaneous. So it can be discontinuous and it can jump because maybe you want to extract a payment at a specific point in time. Okay.
So is there a reason you're not allowing the mechanism to sell the buyer messages throughout time?
What's the reason?
You could imagine I can try to give the buyer rewards, not just by adding the third, but also slowly, right? We have doing some sort of dynamic.
Right. I think we're restricting primarily because we think application-wise, sellers really are controlling more of this pricing and access thing, and so the inference the buyer is making is purely based off of the two observed, right, I and P, and so we could allow. I think that's an interesting thing, but I'll leave it for discussion.
Okay.
So the first thing we want to ask was about dynamic mechanisms, and so let's suppose the mechanism is designed by a third party. So for now, I'm going to try to step away from the signaling consideration or the fact that proposing a mechanism itself has some informational content. So let's just suppose that someone else is setting the mechanism or decided the mechanism. If the high type seller gets some profit pi h and the low type gets pi l, what are the payoff outcomes that we can expect? And so really what this means is we're going to solve for an incentive compatible, individually rational dynamic mechanism with Pareto weights that we'll assign. So we'll reweight how much we value the high type and low type sellers payoffs, and we'll scale the low type by this weight WL. And it just has to be incentive compatible and individually rational when the buyer is starting with this belief view. In a couple of slides, we'll get to signaling considerations. And so our informal theorem is that the solutions to this problem are trial mechanisms. And so what do I mean by a trial mechanism? Well, to formally define this, I'll have to separate the histories into two classes, right? There are histories where no signal was reported by the buyer. And so these are any time where the buyer has not yet raised their hand. And then there are histories after which the buyer has raised their hand and they reported some value VS at time S. And so we're going to separate, simplify the notation a little bit. I'm going to say IU is like the access that we provide at time T if no signal gets reported, and IVS is the signal with some is the access when a signal is reported at time S, which is less than T. And so a mechanism is a trial mechanism if, regardless of seller report, this is true. So to highlight, I'll walk through this. The first thing is that the uninformed seller or uninformed buyer, sorry, if no signal gets reported, they get access 1, full access up until a time threshold T0, and then 0 after. And so even if I don't report having seen any rewards, I still enjoy access to the service up until some time threshold. If I ever report having seen a reward, then I for sure, regardless of what time it is, I will get full access if my value is sufficiently high, if my reported value is high. Otherwise, I get treated as if I was uninformed. So if I still have trial length remaining, I will still use the rest of my time trial at this premium access, but then I get cut off. And so the prices then reflect sort of this structure, which is that at time 0, keep in mind these are cumulative prices, so it being constant means that at time 0, I'm making this payment of P0. And then if I ever report, I get this additional price jump that I have to pay, which is the expected reward I will have for the remainder of the service after the trial. So really intuitively, this is saying that a trial mechanism is, well, I'm going to offer to sell you at some price P0, this initial chunk of time, T0. And depending on whether or not you report to me having seen a good signal arrive, you can have this option to upgrade for the remainder of your service, and you would get the rest of the service.
So is it important here that the seller has 0 marginal cost of providing a service?
Yeah, we have some extensions where we have add a little bit of a marginal cost and flow utility, but I'll defer that offline. Okay. And so the payoff set, or what this will end up looking like, is something along this line. And note that it depends on sort of what weights we assign to the high and low types. In point B, where the weights correspond to the prior, this turns out this trial is kind of degenerates, and that the length of the trial is the entire service. And so what is effectively happening is I'm selling the entire service. Exactly, I commit to giving you 1 for all time, and I'm just going to extract a lower price according to your belief on my quality. At point H, which is the mechanism that maximizes the revenue of the high type seller, this will look something like a discounted trial where the high type seller will charge some amount of some fee that is reduced for this lower trial period. And then after the trial, they are able to exploit the fact that the buyer likely has learned and extract revenue from that. And in fact, another interesting point is when you try to maximize the difference between the high and low type sellers payoff. So the weight would be -1 of the low seller, and that corresponds to a free trial. In fact, during the trial, I in fact don't even charge a price initially, and so I'm willing to let you use my service for free up until some time, after which I can extract rent from you if you have received a good signal. And so as we move along this frontier from B to H, or from B to H to F, what actually happens is this trial length starts getting shorter and shorter, and from an efficiency perspective, again, it's a little bit stylized in that we want service to be provided at all times. So the volume of trade is decreasing as we move along this frontier. I did say I would talk about equilibrium a little bit. So we'll start with the normal notion of a weak perfect Bayesian equilibrium, right? The seller is the best responding to buyer, buyer's best responding to seller, and buyer beliefs are consistent with strategies and Bayes' rule where possible. But we're going to add first 2 little refinements that we'll consider pretty weak. The first is that the buyer must be convinced of the seller being a high type if they saw a reward. This really only has bite when the buyer for some reason decided with zero probability. For some reason, because of the mechanism proposal, I somehow decided to assign zero probability to you being a high type, but if I see a reward, I have to be convinced. And the second one is we're going to focus on equilibria where the high type gets weakly more than the low type seller. And so as a benchmark, this point B we said was sort of the one that maximizes ex ante revenue. And B is always in equilibrium if one of the following is true, which is if we take away either the informed seller part or we take away the dynamic part. And so this echoes the result from Kessler and Schreda, right? B is always in equilibrium if you can't observe this match quality or if you only do things statically, where having this information on the part of the seller doesn't really hurt the seller in this static environment. In contrast to that, in our environment, because of this avenue for the high type seller to possibly offer a credible deviation, specifically the key deviation is the free trial. A payoff pair only is in equilibrium if the high type seller gets at least as much as their free trial pay. And so it depends on the parameters, but the shape could look something like the right-hand side, where the ex ante maximizing point B is in the equilibrium set, or it could look something like the left-hand side where there is a loss of efficiency as a result of these signaling incentives. And when should we really expect this inefficiency to arise? Well, this free trial payoff gets better when learning is faster, when the market belief is more pessimistic, and the monopoly pricing is more attractive. I'm going to skip the D1 slide. If you're interested, I can talk about which stronger refinement criteria. And so the last thing we wanted to get to is what if the seller has more control over not just this like access parameter, but a richer set of controls over the learning rate and the utility that the buyer receives. And so in the baseline, you can think of this as like we have this line, right, which is the learning rate and flow utility are perfectly linear, but you can imagine that you could have more control over what you can do. And so roughly our results here are that the relevant mechanisms are things that we call tiered pricing, where an unconvinced buyer gets a degrading service offering with the choice that they can upgrade to the best service possible as it goes. And so in the trial, that kind of looks like just moving from point 1 to 2, but in this more general environment, that the service that the unconvinced buyer gets starts as really good, and then eventually is this like kind of degraded option before finally getting cut off. And we want to highlight that this richer screening gives the high type seller more ways to prove themselves and can possibly lead to worse revenue overall on average. Okay, so running low on time, but revisiting these 3 questions that we sought out to answer, sort of what dynamic pricing mechanisms, we found that sort of the solutions to this design problem were trial mechanisms. And how do signaling incentives affect equilibrium mechanisms? Unlike the static case, the informed seller can be worse off because of this dynamic channel. And how does the seller screening technology? The seller ends up using tiered pricing, and enriching this screening technology to end up hurting this. Think about it.
Like because I feel like this framework is more general in the sense like because like the high type seller wants to convince like the buyer is type but like once like the conclusive good news receives like you we have like the bias and price, but like what if like the two private information they do not arrive in the same time? Because here it's like once you know like the seller's type, like you immediately have your private information, right? I'm saying in general here it's like report.
So there is some degree to which you can separate sort of the additional learning about the additional learning the buyer has about like learning B exactly from the learning about theta. We did consider it. We have like some notes on it, but